You have probably seen this tiny little t next to a matrix in machine learning formulas and just brushed past it. But what if I told you that this simple transpose operation is one of the most important gears in the entire machine learning engine? It's not complex, it's not flashy, but without it, crucial operations like solving for model parameters and even the core of how neural networks learn, they just fall apart. In the next 3 minutes, we are going to decode what the transpose really is and how to do it in one character of Python code, and why mastering it is a non negotiable step before we can build our first machine learning model from scratch. So, what is a matrix transpose? It's simply the operation of flipping a matrix over its main diagonal. The rows becomes columns and the columns becomes rows. Let's take matrix A of 3 rows and 2 columns. Imagine a line running through the top left corner down to the right. That's our main diagonal. To find the transpose, which we write as A superscript T, we simply pivot the elements around this line. The matrix A transpose would contain 2 rows and 3 columns. And that's the core concept. The first row becomes the first column, a 3 by 2 matrix becomes a 2 by 3 matrix. And we have literally just changed the orientation of our data. But the power isn't in the operation itself, it's in what it allows us to do. As practitioners, we don't do this by hand. In Python, the NumPy library makes this a one step process. We define our matrix as a NumPy array and then simply call the t attribute on it. One character. That's all it takes to perform this fundamental operation. You will use this constantly in real world machine learning code. Okay, it's an easy flip. But why is it an unsung hero? Here are the two critical roles the transpose plays in our work. First, it's the master of alignment. In our last video on matrix multiplication, we learned that the inner dimensions must match. The transpose is the tool we use to reshape our matrices to make those operations possible. It's the universal adapter in our mathematical toolkit, ensuring our data flows correctly through our models. And second, and this is the big one, the transpose is a key that unlocks our ability to train a model. This is the normal equation for linear regression. It's a powerful formula that directly calculates the optimal parameters for a model. And look, the transpose is used twice. It's essential for calculating the relationships between our input features. Without the transpose, this entire solution is mathematically impossible. So, the matrix transpose isn't just a simple flip. It's a fundamental tool that lets us align our data and prepare it for model training. But it's only one half of a powerful duo. To truly understand that equation we just saw, we need its partner, the matrix inverse. And that's exactly what we will be decoding in the next video. Once you understand both the transpose and the inverse, you will have all the fundamental tools you need for our next big step. I'm excited to announce that after we complete this foundation series, we will be launching a brand new series called the ML Internals, where we will use these tools to build models like linear regression completely from scratch. If this was helpful, hitting the like button is a huge help. Be sure to subscribe and turn on notifications so you don't miss the rest of our foundation series and you are the first one to know when ML Internals drops. Thank you for watching, and I'll see you in the next one.